Okay, so just like we've done in the last videos, let's start by saying this is what we've got already. I've got a final position. I want to know my final position if I have a constant velocity. So this is my final position with constant velocity formula. I want to do the same thing with velocity. I want to know my final velocity if I have a constant acceleration. Okay, and then we created a formula that said, well, if I've got a constant acceleration and I want to find how far I go, but I don't know what that acceleration is, but I do know what the final velocity is, I can say x equals x0 plus 1/2 times v0 plus v times time. Okay, and so now I've got my final position or my displacement if I have both my initial and final velocity. And so we're calling this displacement with constant acceleration. And saying constant acceleration reminds me that I can just substitute my average velocity in there. And then we also just created a formula that tells me that I can find how far I go if I just have my initial velocity and the acceleration with no final velocity. So we called this the displacement with constant acceleration, no final velocity. Okay? So these are my first four. Now, I desperately need a formula that I can use to solve for things if I don't have time. What if I haven't been given an amount of time? You can see all these other formulas have time in them, but what if I haven't been given time? So hopefully it makes sense that we could do the same thing that we did in the last one. I could find a formula maybe that I can set t equal to the rest of the formula and substitute that in. So here's what I'm going to do. I'm going to start by saying find a, and this is below the line, here's what I want you to put in your notes. Find a formula that I can solve for time and then substitute that in for t in another formula. Okay, and we'll use the same formula we used for the last one to substitute into. Last time we used x equals x0 plus 1/2 v0 plus v times time. And last time we substituted in for v, right? We didn't have final velocity, so we substituted something else in for that. This time we're going to substitute something in for t. And we're going to use the same formula we used last time, except we're going to isolate t instead of v. And so if we start with v equals v0 plus at, we can solve for t by first subtracting v0 from v, okay, and then dividing by a, and that will give us t equals v minus v0 over a. Okay, now this is going to be a little bit more tricky because we're going to have to substitute this in for t, and the algebra is going to be a little bit more difficult. So let's substitute this in first. So I'm going to say, hey, let's put this in for t here. And if we do that, we get x equals x0 plus 1/2 times V0 plus V times V minus V0 over A. Okay. Now, I can shift this around a little bit. I can simplify this, and some of you that are less secure in your algebra skills are going to find this uncomfortable. Again, I'm not asking you to be able to do this. I just need to show you where these formulas came from so that you're not just sitting here. Marshall just makes us memorize formulas and doesn't show us where they come from. Okay, so let's rearrange this. Let's put the 2 under here and we'll create this. We'll say x equals x0 plus, and I'm going to switch the characters here. I'm going to say plus v plus v0 times v minus v0, and let's not have that little dot in there. V minus V0, and I don't know why I put the 1 in there either. V minus V0. Okay, so all I did was I switched the order of these and put these, and then let's just put this all over 2A. Okay, so the first thing I'm going to do is I want to rearrange this, and ultimately I'm going to get my final velocity on one side and everything else on the other side. Okay, so ultimately I'm going to get my final velocity on one side and everything else on the other side. Okay, so in order to get final velocity on one side, I'm going to need to get rid of the 2a and the x, the initial velocity. So I'm going to subtract this. I'm going to subtract x0 from x and get that on the other side. And so now I have x minus x0 equals v plus v0 times v minus v0 all over 2a. Now I'm going to get rid of this denominator. Okay, I'm going to multiply this on the other side by 2a, and so I'm going to say 2a times x minus x0 equals v plus v0 times v minus v0. Now, if I remember my algebra, if I were to multiply this out, this is the same thing as a difference of squares. Okay, I'm going to end up with v squared, okay, plus, or v squared minus v times v0 plus v times v0 minus v squared. So I'm going to end up with this 2a times x minus x0 equals v squared, okay, so v squared minus v v0 plus v v0 minus v0 squared. Okay, that's going to drop out. So I end up with v squared minus v0 squared, and I'm going to add the v0 squared to the other side of the equation. So I'm going to end up with v squared equals v0 squared. So if I, again, added v0 all the way over here, v0 squared plus 2a times x minus x0. And this is our last formula. And in fact, we'll end up calling this the last formula because it's the last in the list, and that'll be helpful to us as well. but we're going to call this displacement with, I'm sorry, not displacement, my bad. We're going to call it, because what we end up with is final velocity, right? So final velocity with constant acceleration You're like, well, wait, Marshall, we've already got one of those too. I've got final velocity with constant acceleration. But we're going to distinguish this one by saying no time. Final velocity with constant acceleration, no time. And yes, I know this is v squared, but we're still just going to say final velocity. Okay, so that's this formula, and now we have completed our 5 formulas, and now we'll go ahead and summarize these, and then in the next lecture we'll say how we're going to use them. Okay.